Do you remember from the beginning of the unit when we talked about the segment addition postulate? Remember, a postulate is something that we accept to be true without proof. It's so basic and practical that it doesn't need further explanation. If you remember, the segment addition postulate said that the lengths of the parts of the segment add up to the whole length of the segment. The same is true for angles. The measurements of the parts of the angle add up to the whole measurement of the entire angle. With this understanding, we can start to find the measurements of these angles.
Our next idea here is this angle addition postulate. If P is in the interior of angle RST, then the measure of angle RSP plus the measure of angle PST is equal to the measure of the whole thing, the measure of angle RST. Let's zoom into this picture to get a better idea of what that means. You can see P here is in the interior of the whole angle. Here we have the outside and the outside. The angle addition postulate says if I add one part of the angle, RSP, plus the second piece of the angle, PST, we get the entire angle measure, RST. We're going to use the language that we use similar to segment addition postulate. Part plus part equals whole. Part plus part equals whole. Let's use that in an example here. Here in our example, it says that we know the whole angle PQR has a measure of 102 degrees. This whole angle has a measure of 102 degrees. Our job is to find the measure of each individual piece. So to start that process, I have to find the value of x. So if our rule is part plus part equals whole, that's exactly how I'll set my equation up. 7x minus 5, that's part 1, plus 9x plus 11, that's part 2, equals whole. We know the whole thing equals 102 degrees. I'm going to use my Algebra 1 knowledge to solve this equation. On the same side of combined like terms, 16x plus 6 still equal to 102 degrees. I remember if I move across the equals sign, then I have to do the opposite. So I'm going to subtract 6 from both sides. And I get 16x equals 96. Use my calculator if necessary to divide 96 by 16. And I find that x equals 6. But my directions didn't ask me to just find x. They asked me to find the measure of each of those angles. So now I'm going to use my x. I'm going to plug into each angle to find their values. So if I plug into the first part, I have 7 times 6 minus 5. Which tells me the measure of angle PQS is equal to 37 degrees. Now I'll plug into my second angle, 9 times 6 minus 11, and I find the measure of angle SQR is 65 degrees. Let's think about how we can check our answers. How do I know that I have found two reasonable answers? Well, one way I can do that is to add these two measures that I found, 65 plus 37, and ask if that equals the original total that they gave me, the original value for the entire angle. And sure enough, they do equal 102 degrees when added together. Our last concept of the day, found here at the bottom of our note page, was also something that we used with segments. So hopefully it's an easier concept for you to catch on, hopefully. An angle bisector. Bisector should be familiar to you. It means it's cut into equal pieces. An angle bisector is a ray that divides an angle into two congruent angles. So it's directing us to this figure to the right. It says that ray YW bisects angle XYZ. W's here in the middle. It's bisecting. So what that means is angle XYW is congruent to angle ZYW. And you can see that. We'll zoom in the picture. Instead of having tick marks, we have these green arcs in each corner. That's our clue. That's our notation in a picture for saying that this angle has the same exact measure as this bottom angle, because this ray in the middle is bisecting. So let's use that idea here of angle bisectors in an example. Here it tells us that ray BD bisects angle ABC. I don't see that with my mind, so I'm going to draw myself a picture. There's a ray. Here's another coming out of the same end point. We'll call this angle ABC. We're going to put a ray in the middle to bisect. We'll do our best to make sure it's in the middle. We're going to say that looks like the middle. Okay, so there's our picture. We have ray BD bisects angle ABC. So that also means in my picture, if it's bisecting, these two pieces are congruent. And we know that the whole angle has a measure of 158 degrees. The measure of angle ABC, this whole picture, measures 158 degrees. Our job is to just find the measure of angle DBC. Our job is to find this angle here. But if we can call that angle DBC, if we can call it X, we can also call angle DBA above it X. And that's due to those green marks of congruence. We know they have the same measure. So I can use that information to write an equation. X plus X, part plus part, equals the whole thing. I can algebra 1 this equation, combine my x's, divide both sides by 2, and I find that x has a value of I was going to rewrite the whole total, of 79 degrees. But they didn't ask for x, they asked for the measure of angle DBC. So I have to say the measure of angle DBC is 79 degrees.
This is just an introduction to some basic knowledge about angles. We'll continue to work with angles throughout the rest of this course. And maybe, if we have time, we can talk about angels. Oh, what's that? Oh, I'm being told we will not have time.